Now I want to have a look at writing a simple lambda expression that consumes a lambda predicate expression. This is coming from the Java 8 OCA 1Z0 808 topics. We need to revise first of all our interfaces before we get to that. In general, when you create an interface, you're defining a contract for what a class can do without saying anything about how the class will do it. You sign this contract with the keyword implements. When you're implementing an interface, you're agreeing to adhere or obey the contract defined by the interface. If a concrete class is implementing an interface, the compiler will ensure that the class has implementation code for each abstract method in the interface. Whereas a class can extend from only one other class, a class can implement many interfaces. So if we say class dog extends animal, implements movable and lovable, then a dog is an animal, movable and lovable. As of Java 8, it is now possible to inherit concrete methods from interfaces. These would be your static and default methods. Implementation classes are not required to implement in interfaces static or default methods. The default interface methods are inheritable, but the static interface methods are not. Interfaces themselves are implicitly abstract. So even if you leave off the keyword, it's automatically plugged in. Top level interfaces are like classes. They have public and package private access. All of the interface methods are implicitly public. So when you go to implement them, make sure you put in public. They're implicitly abstract unless you're talking about the default or static ones. All the variables are public, static and final. And as with abstract classes, you cannot new an interface. A functional interface is an interface that has only one abstract method. This is known as the single abstract method rule, or SAM. Default methods do not count when you're counting them up. Static methods do not count, and methods inherited from object do not count. And there's a sample one, FI, that's a sample functional interface. You've got void M, that is the only abstract method there. And that's what you need, just one. Lambdas. A lambda expression is just a block of code that helps in making your code more concise. Less characters in your code, less keystrokes pressed. A lambda expression only works with functional interfaces because the compiler cannot make a decision for you as to which method you're talking about. So therefore, there can be only one method, that's the abstract method. That's why it only works with functional interfaces. The compiler knows straight away what method you're talking about. A lambda expression is an instance of a class that implements a functional interface. So the compiler is doing quite a bit of work in the background. Lambdas look a lot like methods, and in some quarters are called anonymous methods. However, they are in fact instances of classes that implement the functional interface in question with everything but the method stripped away. A lot can be inferred or figured out by the compiler from the interface definition, which remember has only one abstract method, the functional method it's called, because you're dealing with functional interfaces. The lambda expression is the instance that implements the interface that has been boiled down to the bare essentials. Here is a piece of code. I've got an interface I which has a void method M. That is a functional interface. It has only one abstract method, that method M, no curly brackets in there. Then I've got inside in main pre-Java 8. This would be the way in pre-Java 8 of implementing that interface using an anonymous inner class syntax, where you have the interface I, that's just declaring the reference, is assigned new I. Now you can't declare an instance of an interface, but that is what that's doing. That's just the syntax of it. The curly bracket that you see here and the curly bracket that you see here are in fact the class code. That's the code for the class that's implementing the interface I. Semicolon at the end there, that is in fact the semicolon of that particular Java statement. In between the two curly brackets is in fact the class code. And what we've got to do is we've got to override that method m, which is what we're doing there. And all we're doing is we're outputting I colon m to say this is the interface I, and that's the method m. Then I call it, I execute it on that line there. I define it, and then I execute it. Then on Java 8, when lambdas come in, here I'm going with lambda I, and there you can see the round brackets. That is in fact the round brackets that you see up there in void m in the interface definition. This is the declaration of the lambda expression. Code will not be executed yet. So that takes in nothing, no arguments coming in there. And the arrow says, well, what's the code for the method on the right hand side of that arrow? Left hand side, you've got the declaration of the inputs coming in, if there are any, and on the right, you've got the code. So we're putting in a block of code in this instance. Note the semicolon there is just the end of the Java statement. Inside here, we're outputting lambda version. Then I declare another one. I don't put in the block of code in this case. You don't need a block if you're just putting in one Java statement. So the second version, lambda I2, is system.out.println lambda version. That's the declaration of the two lambdas. So you can see there I'm executing the two of them. Lambda I.m executes the lambda version, and I come up with lambda version, and then lambda I2.m outputs lambda version as well.